In class, you will encounter series, parallel, and combination circuits. Series circuit allows current to travel through one path. In the previous videos, we learned the symbol of a battery is two parallel plates of unequal length. The longer parallel plate is positive or high potential. The shorter plate is negative or low potential. By convention, current flows from high potential to low potential. So clockwise for this circuit through the resistor R. Parallel circuits allow current to travel through multiple paths. And again, the high potential is the longer plate. The shorter plate is low potential. Current again will flow clockwise from high potential to low potential. As the current flows through this circuit, it reaches a junction in which the current has more than one path to go through. The current could go straight down or across and down. Because the current has more than one path, it branches off or breaks apart and goes through each branch separately until it meets again at a junction. When it meets again, it will combine as before and continue on through the battery. Combination has series and parallel branches put together. Current again flows clockwise because the long plate is positive or high potential, the short plate is negative or low potential, and current always flows from high to low. As the current leaves the battery, it enters the resistor R. Since there is only one path from the battery to the resistor, the battery and resistor are connected in a series. As the current continues on, it reaches a junction in which the current has more than one path to travel. It could go through R1 or go across and through R2. Because the current has the ability to split, this branch is in parallel to each other. Therefore, R1 and R2 are in parallel. Once the current reaches the next junction, the current meets together and will combine back to its original current. So this portion where the current is split is in parallel, but this parallel branch is in series to the resistor R. In order to solve for circuits, you need to memorize these 6 circuit rules. In a series circuit, the voltage total is the sum of all the individual voltage. So voltage total is equal to V1 plus V2 plus V3 and so forth. In a series circuit, the current is constant because the current only has one path that it can travel through. So the current is constant. R total or R equivalent, the resistance equivalent, is equal to the sum of all the individual resistance. So R total will always be greater than any individual resistance. In a parallel circuit, the voltage is constant. The current is added because when a current reaches a junction, it has more than one path to travel. So if there's multiple branches, the current will break into parts to enter each of the branches. And when the branches come back together at a junction, they will recombine. So I total is equal to I1 plus I2 plus I3. The total resistance RT or REQ is equal to 1 over RT equals to 1 over R1 plus 1 over R2 plus 1 over R3. Therefore, the equivalent resistance is always less than any individual resistance. In the next video, we will start simple series circuits.